Hey, what's up, everyone? Welcome back. This is the second video, and today we will be solving the second question on Codility. And again, hopefully, we will score 100% again. So I'm just gonna explain how it works. I'm just going to solve the problem with you. I'm gonna be thinking out loud. Of course, if you have any other ideas or like a better way to solve the problem, you can leave a comment, or you can actually contact me. Maybe we can create a video about the same problem to solve it in a different way. But for now, let's start with the second question and see what we should do here. So we're gonna skip it, and yes. All right, so again, I'm going to use PHP as a programming language before I even read the question. And just a quick we're gonna go through this here. So we have 2 hours, and again, it's a lot of time. We need to solve it in 15 to 30 minutes maximum. So let's start by reading the question, and not to panic. Yeah, because that's my habit. So whenever I see all these numbers. All right, so we have a non-empty array A consisting of n integers is given. All right, the array contains an odd number of elements. Fair enough. And each element of the array can be paired with another element that has the same value. Okay, except for the one element that is left unpaired. For example, we have this array. So the first thing before we continue, I'm gonna go and put this here, and let's consider that we're gonna print the solution, right? And let us put the array itself. So it's gonna be 939 3979. All right, so it's going to be 939 3739. I guess this is how it is, right? 939 3739. 939 3979. Okay. 3979. Okay. So we have this array, and they're telling us that it's an array of odd numbers, and each number should be paired, right? Okay, so the element of index 0 and 2, 0 and 2, 9s, has a value 9. Okay, elements at indexes 1 and 3, 1 and 3, they are 3. 4, and I guess the 6th one, yeah, it's going to be 9. The element at index 5 has value 7, and it's unpaired. All right, cool. So we need to write a function that, given an array A consisting of n integers, fulfilling the above conditions, returns the value of unpaired elements. For example, so we have the same array as the example, and the function should return 7. Okay. All right, so we just need to come up with a way to separate the unpaired element or item in the array. Write an efficient solution. Okay, and here again we have the conditions or the constraints we need to check for them. Okay. All right, so sorting here will not help. I'm gonna just try to, because we're talking about numeric arrays, so sometimes sorting, you need to find a way to iterate through them. Okay, so let's take this for example. That's the first. Since we're gonna iterate, we're gonna create the length, right, which is the A. Now, as we do always, let's keep it here. Say to do, we need to check for all the constraints. So if I want to use this for I equals 0, I is less than the length, then I plus plus. Okay, so if I want to just, so we're going to be using just the linear iteration for now. I'm not sure, maybe later on we can find a better way to do it. All right, and let me just here kill it. If we clear this, we are at lesson 2. Wow, that's an infinite loop. Okay, I is less than the length. Oh, wow. So the length is going to be, that's an important thing. Length is going to be the count. All right, cool. So 939, blah, blah, blah. Okay, we got it. Now we need to check if it's paired or not. So one way to do it, which is I don't really recommend it, which is to bubble search it, which is not recommended. Like if I go through the 9 here, if I take the 9 and I loop through the rest of the array, you know, and see if that count is actually an even number. But this is, again, this is the execution time for the solution is not going to be efficient. So what am I going to do? I'm going to create another array, which is, let me call it, I don't know, duplicates. Okay. Again, the array here, we're going to be, if this was like a production code, I would use the SPL array, fixed array. Or at least to convert to, after we come up with this array, to convert the final array to an SPL array, just to reduce the space in the disk. All right. So what am I gonna do here? I'm gonna check every item if it's inside the array or not. If it's inside the array or not. So if I say this, if an array, all right, just to remember an array takes the needle first. So if in array A of I, all right, inside this, okay, no, I need to say if not in array, then just add it, right? If you are not in the array, just add it. Okay. If you are in the array itself, if you are in the array itself, but this way I won't, if you are in the array itself, okay, let's continue. Okay, if you are not in the array, if you are in the array, let me do this. Just, if you are in the array, then I need to unset. Okay, I want to unset it, but I can't unset it by value using the unset. Unset, we can use the keys. So instead of in array, I'm gonna use if array key exists, key, and then search. So this is the key. Okay. If we have the key here, if we don't have the key, then I'm gonna say you are my friend a 1. All right. Cool. Okay, so if the key is there, otherwise we're gonna unset duplicate this one. So technically what I'm doing here, I'm checking if this number, so I'm gonna be using the values as indexes in the other array. So we should expect duplicates to be an array like 9 that has the value of 1, we can 0, or we can put here the amount of times that this number appeared in the loop, or in the array, in the previous array. So what I'm gonna be saying here, if array key does not exist, I'm gonna set it as 1. So this is the first time that this key is or appeared in the duplicates array. Otherwise, so if that key is actually inside the array, I'm gonna unset this key. So what I'm trying to do here is the final result of the duplicate array should contain one or more duplicate numbers. So if we have, in this case here, if we have one duplicate number, I should have it inside the duplicate array. So let's try it out. If I do, okay, we are printing R, so I just need to return it for now, right? Okay, so fine. So it makes sense right now. It makes sense because 7 didn't appear, so we didn't unset it, right? So 7 has this value. This will only work if we have only one unpaired element, because to find out what is the element, we need to find the key of that of the duplicate. So if I return the key, I'm going to return 7. But if we have multiple unpaired elements for some reason, or I guess that's because it's an n and n is odd, so I guess we will always have 1. Anyway, let's check the conditions. Maybe we're gonna find out something. So here, n is an odd integer within the range 1 to a million. Okay, and n, we say it so. Okay, so the amount of, or the size. So the size of this array should be between 1 and 1 million. So let's do that. Let's do that. So we have here the length. I'm not sure if we have an empty array, how we're gonna solve it, but let's see. So if the length, right, is less than or more than equal than 1, and the length is less or equal than, what did we say, 1 million, just to make sure, because I don't really trust these numbers. So if we got it right, then that's gonna affect our score. So let's just do it like that. So if the length is the count, okay, so fine. Cool. So this is our first check, right? The second check, it's gonna be each element of the array. So all right, so either way, we need to iterate through the loop, because other than that, you're not gonna be able to check every element. So like either way, it's gonna be a linear loop. So each element of array A is an integer within this range. Okay, so we're gonna do the same thing, but we're gonna pay attention to integers. So integer means that we're gonna be checking here before everything. We're gonna be checking is integer. If integer ai, okay, if you are integer, and so I don't want to check, I want to actually like prevent it. If you are not an integer, or so if you are not an integer, because if we find something, no, actually it makes sense, it's fine, it's the same, the impact is going to be the same. So if you are an integer and you are more than or equal than 1, and you are less or equal than this number. Cool. So these are the conditions for now, right? We can, of course, remove the else, put continue here, but I'm gonna keep it that way for now. It's more, say, understandable. But the thing is, what if the array is empty? What if the array is empty? So I'm gonna be checking because we're gonna return the, okay, count. I'm gonna be like, if empty this, then I don't know, since we are returning an integer, right? I'm gonna just return 0 if it's empty. Other than that, the length should be between like this range, and every yeah, and then every element should have this. All right, cool. And then we're gonna continue our check. So let's try to run the same code, and we should get 7. Yeah, it's working. All right, but what if, let me try just one thing. What if it was an empty array? We're not gonna go back to the key, and we should get 0. Yeah, cool. So it didn't break our code. I'm just trying to try to prevent the, exceptions or anything, fatal errors. So so we solved these two, or we prepared them, and then all but one of the values in A occur an even number of times. All but one. So yeah, so in this case, we're good to go, because if they appear in an even number of time, just 1 second. Here, it's an odd integer. Okay, within the range. So we need to check if it's odd, actually. Okay, so the length should be an odd number. So alongside these, we need to be like, if length, the odd number, mod 2 not equal 0, right? Yeah, and so let's do this. That's how we're gonna be checking for the odd. So yeah, now we covered them. So if you are an odd and with the range, and then each element is inside this range, we got this range right? I guess, yeah, hopefully, correct. Therefore, once we return one element, that means every or all the elements inside they have like paired or even values, or occurred in an even number. Okay, that looks good for now. It's actually pretty straightforward. I don't see like a problem or the need to use like a specific algorithm for this. Let's hope we just get it right. So let me see here what we're gonna do. We're gonna do that. Okay, so we have everything set. Cool. And then again, I'm gonna remove myself here, and we're gonna run the tests. Okay, so we passed the initial tests, or test, it's only one. And then again, we have like performance, we have correctness tests after we submit. Let's see our score. Hopefully it will be, like, I don't see, to be honest, I don't see, unless maybe something to do with the range, but I don't see how we can break the code here. Okay, let's put it here. They're still calculating. I guess since if it takes time, then they're calculating the performance, I guess. All right. So again, we got it 100%. Here in this task, remember the first question, they didn't really check for the performance. So even the results, the results was like, we got the results faster. And it took us like 18 minutes. All right. So the first question took us like 20. I expected this one to be like 10. All right. So yeah, so we got 100%. And here you can see your code. This is the performance detected. Okay. So it's going to be, it's either linear in the worst case scenario, or we're going to get the end log. Okay. Cool. So here you can see the test. This is the one we passed. And these are all the tests, medium, big. Yeah, so they were testing for the array size and I believe median random, yeah. So yeah, that's it. It was pretty straightforward. I actually like this question. So again, if you have a better way to solve the problem, please just leave a comment. Let's learn from that. And the next video is going to be about the third question in Codility. I'm not sure. I can't really remember what is it exactly. So we'll see you then, and bye bye.